example 3, in this example, okay, now we assume, okay, we assume the plus hinge we don't know the location of the plus hinge for the real collapse case, but we can determine 3 possible plus hinges location. One is at point B, because this is a connection, and for point C, this is a force application location, and for point D, this is a connection. Okay, please understand, point A and point E are not plus hinge because they are pin supports. The moment already equal to 0, so it is impossible to have a plus hinge here. Okay, and we consider different collapse mechanisms. The first case is the beam, okay, collapse mechanism. So we can obtain, okay, the energy equation for the external force as well as internal force. This is a very simple case, so we don't need to talk in detail. And this is the second case. Okay, for the second case, please understand we only have 2 plus hinges. We only have 2 plus hinges because the beam keeps horizontal, and the 2 support at the base, okay, the 2 supports at the base are simply supported, so they are not plus moment, plus hinge. So we can obtain, okay, this is the equation. From this equation we can obtain P2, okay, and then we also have a combined case. Okay, actually we have 2 combined cases, but the result obtained from the 2 combined cases will be the same. Okay, will be the same. So we just need to analyze one case. So here we assume the left connection is a radial connection. So it's easy to obtain the external energy and the internal energy. Okay, so for this point, the rotation angle totally is equal to 2 theta. And here again, please understand, at this point we have a rotation for both beam and column. Each element has a rotation equal to theta, so the total rotation angle is equal to 2 theta. Okay, so we can obtain the result. And then finally, just need to compare, okay, it's P1, P2, P3 from the 3 cases, and then, okay, you pick up the smallest one. And this is the lowest value. Okay, this is a lowest value. So this is a real collapse mechanism, but you still have to do the moment check. Okay, in the combined case, we assume this is a radial connection. Okay, this is a radial connection, so you have to calculate the moment for this section. Okay, here I provide the result of the moment for this section. I will do the moment. I will show you how to do the moment check. Okay, so we have to do the moment check for section B because the obtained collapse force is corresponding to the combined case, and for the combined case, as a possible plus hinge location B, we assume moment for this section is less than the plus moment. That means it is not plus hinge, but we have to check. Okay, so here's the result. Okay, but I will show you how to obtain this result. Okay, so we have to obtain the moment for this section. Because if you want to obtain the moment for this section, you just need to take B as the value of P3, because P3 is the lowest value. So you replace P by P3. And because P3 is obtained from combined case, and in combined case we have plus hinges at point C and point D. So you just need to replace section C and section D by plus hinges. Okay, so this is a base. And then we can do the moment check. When we do the moment check, because for the plus hinge, you don't need to worry about the positive and negative sign for the rotation and the moment, because the internal energy must be positive. Okay, but for section B, it is not plus hinge. So the moment can be either positive or negative. We don't know the direction of the moment. So when we do the moment check, you have to introduce a sign convention. So now I show you the sign convention. Okay, here is a sign convention. For we assume, okay, the moment is positive when the moment is a second moment. Okay, for second moment, we assume this is positive, and for hogging moment, it is a negative. Okay, so we go back to this case. In this case, under the application of point B for this plus hinge, the moment is a second moment, right? The moment is a second moment, so the plus moment, the moment C is equal to positive MP. Okay, positive MP. And the moment at point D, okay, the moment at point D is applied, okay, it makes a tension at the top of the section. So this is a hogging moment. Okay, so the moment here is in this direction because the diffraction is like this. So if you want to produce a diffraction, moment must be in this direction. Okay, so this is the second moment. We assume the second moment is a positive. For this point, originally this is a normal angle. Okay, 90 degrees. So you have to apply moment in this direction to produce, okay, the relative rotation angle, okay, lower than, okay, 90 degrees. So the moment must be applied in this direction, and this moment is a hogging moment. Okay, so the moment here, the MC is equal to positive MP, and the MD is equal to negative MP. And for this location, we don't know the moment direction. Okay. If you obtain the positive moment, that means this is a second moment. If you obtain the negative moment, means this is a hogging moment. So we don't know. And how to obtain the moment for this location? You have to introduce virtual displacement because we always use a virtual work method to obtain the moment for this section. Okay, but please understand. Okay, when we obtain the correct force, we use, okay, the virtual displacement like this. Okay, virtual displacement like this. This is also virtual displacement. But when you do the moment check, you can introduce, in principle, you have to introduce a different, okay, virtual displacement. Okay, how to introduce this different virtual displacement? You just need to introduce a virtual displacement to make, okay, some moment at this section available. Okay, the moment at this section available. So usually we don't need to, you just need to forget this, okay, diffraction configuration. You just need to go back to the original structure. Okay, we go back to the original structure, and the P is equal to P3. And corresponding to P3, here is a plus hinge, and here is a plus hinge. Okay, here's a plus hinge, it's a plus hinge. So you just need to introduce any virtual displacement which is allowable, okay, by the deformation. For example, if you want to make a rotation, okay, if you want to make a diffraction like this virtual diffraction, this is not allowable because here we don't have a plus hinge, so the relative rotation is not allowable. Okay, so we cannot have a virtual displacement like this because because we would like to obtain the moment for this section, so we can introduce a hinge here and then apply another moment. Okay, so for this section, you can replace, okay, the section, the radial section, okay, by the pin connection and one another moment. Okay, so in this way, the rotation for section B is allowed. Okay, definitely you have to make, okay, rotation for section B. Otherwise, you cannot obtain the moment because the virtual work is equal to the moment times the rotation. So if you want to obtain the moment for this section, you have to allow, okay, this section, okay, allowable. Rotation is allowable. Okay, and because this is a plus hinge, so rotation from this section is allowable, and also the rotation, this is a plus hinge, so rotation for this point is allowable. So we can introduce a virtual displacement like this. Okay, we can introduce a virtual displacement like this when you have you have a virtual displacement like this. Okay, point B, okay, has rotation, and this is the plus hinge, and also here's the plus hinge. So the rotation for these 2 points is allowable. Okay, so we can introduce a virtual displacement. But for the virtual displacement, we still have to introduce a sign convention, because for the moment, we already use a sign convention. And we can introduce a virtual displacement like this, and also we can introduce a virtual displacement like this. And actually, we can introduce a virtual displacement, combine virtual diffraction and horizontal diffraction. Okay, so actually, you just need to define, okay, as a virtual displacement as simple as possible. Okay, why I mentioned this issue, I will show you. Okay, so here if we introduce a virtual displacement like this, okay, we also have to define the positive and the negative for the rotation angle. Okay, so this is sign convention. Okay, if the rotation, okay, is corresponding to the second moment, this rotation is a positive. For example, this rotation for this point, okay, the rotation must be due to the moment applied in this direction. So this is a positive direction, because this is due to the positive moment, due to the second moment. Okay, and for this rotation and this rotation, the moment must be applied in this direction and then in this direction. So this is a hogging moment. So the rotation due to the hogging moment is a negative. The rotation due to the second moment is a positive. So it's very easy to understand. Okay, so we assume, okay, second moment as a positive moment, and the corresponding rotation is a positive rotation. Okay, positive rotation. Okay, so for the previous case, we can introduce a virtual displacement like this. Okay, and then we can calculate the work done by external force, okay, as well as work done by the internal force. Okay, so if you want to calculate the moment at the point B, MC is equal to positive MP, and MD is equal to negative MP. Okay, and the MB is unknown. We don't know the value about MB, and also we don't know the direction of MB, but don't worry about that. Okay, and we introduce a virtual displacement like this. This is an independent virtual displacement, okay, for the purpose of, okay, calculating class moment at the point B. But maybe you have a question for me. Actually, this virtual displacement, actually it's just the virtual displacement we use here. We use here. Okay, so when we calculate the correct force for the beam maximum, we introduce a virtual displacement like this. So this virtual displacement is same as the virtual displacement we introduced to calculate the moment for section B. This is the virtual displacement. Okay, so this is the equation. So work done by the external force is equal to force times the diffraction. Okay, force times the diffraction, so it's equal to P times delta. And at point B, we don't know the moment, so MB times rotation. This rotation is a virtual rotation. Okay, and this virtual rotation at the point B is a negative rotation angle. At the point C, this is a positive, and at the point D, it is a negative. Okay, and the MC is a positive, and the MD is a negative. So from this equation, we obtain, okay, we obtain the MB value, and this is the value of the MB. You just need to solve an equation to get a solution about MB, because theta can be eliminated from two sides of the equation, and P is equal to P3. So we obtain the value about MB, and the MB is equal to MP over 3. So it is less than MP. So this is a true correct mechanism. Okay, so we can introduce, okay, the virtual displacement like this to obtain the moment for the section B. And this moment is a positive. This moment is a positive. That means the moment applied at the section B is the second moment. Okay, usually at the two ends, the moment is a hogging moment. But for this case, okay, the moment for section B is a second moment because this is a positive, this is a positive, okay? And maybe you have a question, okay, why we use a virtual displacement like this? Actually, you can introduce different virtual displacement. For example, you can introduce a virtual displacement like this. If you introduce a virtual displacement like this, so rotation here is a negative, right? And the rotation here is a positive if you assume virtual displacement like this, okay? So the rotation angle here is a positive theta, and the rotation here corresponding to this point is equal to negative 2 theta, and here is a positive 1 theta, okay? So you just need to change. The moment is always a true value, so you cannot change the direction for the moment, okay? Because this is a second moment, so it is a positive, and this is a Hawking moment, so it must be negative. But virtual displacement is assumed by yourself, so you can assume, okay, the virtual displacement in the downward direction or in the upward direction, okay? So if you assume the virtual displacement in the upward direction, okay, MB is not changed, is unknown, keeps unknown there, and this one become positive 1 theta, and this one become negative 1 theta, and this one becomes positive 1 theta. So the solution will be different. Why? Actually, it is impossible to have a different solution. Actually, the solution is same because not just the terms on the right side changed, and also this term should be changed because force is applied in the vertical, in the downward direction. So if you assume the displacement is like this in the upward direction, so the work done by the force is equal to negative P times delta, okay? Because displacement in this direction, force in this direction, so in the opposite direction. So you also have to change this term to negative P times delta, and then the solution will be same. So the virtual displacement is actually, okay, you can introduce any virtual displacement, but you have to make sure, okay, when you introduce the virtual displacement, the virtual equation can be used to obtain the solution about MB. You have to involve MB in the equation, otherwise it is impossible to get the solution about MB, okay? And also I can show you other cases. For example, you can introduce virtual displacement like this. Okay, you can introduce a virtual displacement like this. You can introduce a virtual displacement including both horizontal diffraction and vertical diffraction. Okay, because if you introduce a virtual displacement like this, you can calculate. Okay, but I definitely do not recommend you to introduce a virtual displacement like this. Okay, of course, when you introduce a horizontal in the horizontal direction, you have to make the beam in the horizontal direction. You have to make beam in the horizontal direction, and then, okay, at this point, there is a change of the rotation angle, and then you can obtain the MB value. So you can assume the virtual horizontal displacement, but I do not recommend you to get the solution this way because the virtual displacement just in the virtual direction can provide you simplest, okay, virtual equation to get the solution about the M value, okay, about the MB, okay, about the MB. So this is a solution. When we do the moment check, you have to use the sign convention, okay, the sign convention. So please understand the sign convention given here, okay. And this is another case, okay. I will do the moment check again for this case, okay. In this case, we have a different plus moment for the two columns and the beam, okay. For two columns, the plus moment is equal to 1 MP. For the beam, the plus moment is equal to 3 MP. So in here, this is assumed. This is assumed, okay, correct mechanism. We just consider one correct mechanism here, and we assume the plus hinge at the point D and the point E, okay, and then we can obtain the correct force, or we can obtain the required plus moment. Okay, if this is a correct force already, you can obtain the plus moment value. Okay, and then you can do the moment check. If the moment check, okay, is satisfied for all sections, that means this is already true solution. Okay, if the moment check is not satisfied, that means this is not true solution. Okay, so firstly, we consider this case. Okay, so we can obtain the plus moment here is equal to 3 MP, and the plus moment for this point is equal to the lesser value, so it's equal to 1 MP, and here is a 1 MP. This is not plus hinge because this is a pin support. So we can obtain the energy. This is work done by the external forces, and for the first plus hinge here, the plus moment is equal to 3 MP. Okay, and then for the plus hinge here, the moment is just equal to 1 MP, but the total rotation is equal to 2 theta because it involves the rotation for both beam and column. For beam, the rotation is 1 theta. For column, the rotation is 1 theta. So totally is equal to 2 theta. So it's equal to 1 MP times 2 theta. And for the plus hinge here, it is just 1 MP times 1 theta. So we can obtain the value about the plus moment. But we are not sure this is a true value or not true value. Okay, so we have to do the moment check. So how to do the moment check? In this case, okay, the other possible plus hinge are located at point C and point B, because point C, this is a connection, so it is a possible plus hinge, and the point B, because this is a force application location. So according to rule 1 or rule 2, it is a possible, okay, plus moment location. So you have to calculate the moment for section C and the moment for section B. Okay, so when we do the moment check, I want to mention again, please forget this figure. Okay, you just need to move this plus hinge, okay, to point B to the original structure, and move this plus hinge to the original structure, and move this plus hinge to the original structure. So we have a plus hinge here, here, and here, and we know the moment for this point is equal to positive 3 MP. Okay, and here is equal to 1 MP, and here is equal to 1 MP, and this is a positive. Okay, this is a positive. And maybe for the column, it's very difficult to define the second moment or hogging moment. But don't worry about that, because you can take off this, you can cut off here and cut off here. And then you can obtain this is a hogging moment, so you know how about the moment applied at the point F based on the moment equilibrium. Okay, based on moment equilibrium. For example, if the moment applied to this column is in this direction, and definitely the moment for point F in this direction is the opposite direction. So even for column, it's very difficult to define the hogging and the second moment, but you know the direction of the moment for the column. Okay, for the column based on the equilibrium equation, And then we go back to the original system. If you go back to the original system, okay, how about the virtual displacement? You have to introduce to calculate the moment at a point C. If you want to calculate the moment at point C, you can replace this point by hinge and one unknown moment. Okay, and then because point D and point E are allowed to rotate, so we can have a rotate for point D and rotate for at point E. So we can introduce a virtual displacement like this. Okay, we go back to the original structure, and then okay, this is a positive moment, and this is negative moment equal to positive 3 MP and negative 3 and negative 1 MP. And if you introduce a virtual displacement like this, here is a negative 1 theta, here is a positive 2 theta, here is a negative 1 theta. Okay, so we can establish a moment check equation. Okay, so this is a moment check equation. So MC is unknown. Okay, so negative 1 theta, and this is a 3 MP, and this is a positive 2 theta, this is a positive, and here's a negative times a negative 1 theta. So from this equation, we can calculate the moment upon C. So here is a result about the moment we obtain. Okay, so the moment from this equation, the moment we obtained is equal to 53. It is less than the plus moment, so the moment check is satisfied. Okay, but just for section C. Okay, and for section C, we obtain the moment is equal to positive 53. So this is the second moment, but you don't need to know the sign. You just need to keep positive 53. That's all. Okay, you just need to keep 53. That's all. Okay, and then we still have to do the moment check for section B. Okay, and when we do the moment check for section B, we have to make rotation about section B. Okay, because we already obtained the moment for section C. So the radial connection at the section C can be replaced by hinge. Okay, by hinge and the calculated MC value. So this point we can rotate for this point after obtaining the moment for this section. After obtaining the moment for this section, okay, this section can be replaced by one hinge and the real moment. Also, this is not plus hinge. This is not plus hinge, but we know the moment. Okay, so we can replace this section by one hinge and obtain moment MC value. So we can have a virtual displacement like this. Okay, we can introduce a virtual displacement like this. If you feel difficult to, because for the beam we know which side is the bottom of the section, which side is the top is a top of the section. Okay, so this is top of the section and this is the bottom of the section. If you want to apply this this convention to the beam, to the column, it's very simple. You just need to, for example, this is a top section, and then this is a top section for the column. And this is the bottom, and then here's the bottom of the section. Again, okay, here is a top of the section. Again, this is the top of the section. This side, right side is top of section. And for this column, this is the bottom of the section. Here is the bottom of the section. Okay, so for the left column, okay, the left side is the top of section, and for the right column, the right side is the top of section. If you assume, okay, column, okay, same as B. Okay, so we introduce a virtual displacement like this. We introduce a virtual displacement like this. Why we can introduce a virtual displacement like this? Because now we already obtained the moment for section C, so we can replace section C by hinge and obtain moment. So the rotation is allowed. Again, because we want to obtain the moment for section B, so we have to introduce, okay, the unknown moment for section C. How to introduce unknown moment for section C? We assume this section, we define this section, individual section, replace this section by hinge and unknown moment. Okay, hinge and unknown moment. So we have a hinge here, and this is already hinged. So we can have a virtual deflection like this. Okay, if this is top side, so here is a positive, okay, this is a positive moment. This is equal to positive 1 MP and the positive 2 theta. Here's the negative 1 theta, and here's the negative 1 theta. Okay, so we can have an equation like this. For section B, okay, for section B, we introduce a virtual displacement like this. Okay, so here's a negative 1 theta, positive 2 theta, negative 1 theta. Okay, and for section C, okay, the moment, you don't need to worry about the moment because you just need to use the calculated moment. The calculated moment is equal to positive 53. So here we use positive 53 times the virtual rotation at the section C plus the moment unknown moment. This is unknown moment. And this is a virtual rotation for section B. And for section A, because this is already hinged, so there is no moment. So this is a virtual force due to some horizontal force. So from this equation, we can obtain the MB value, and we find the MB value is larger than the plus moment. So that means this is not the plus the correct maximum given here. Actually, is not real correct maximum. And you can try to obtain the real correct for moment. Real correct maximum. I can tell you the real correct maximum corresponding to the plus hinge at point B. Okay, it's corresponding to the plus hinge at point B. Okay, so here MP value is not true value. Okay, the MP value is not true value. It is not